Alright, so welcome to this video. We're going to go ahead and continue our discussion on section 3.2. And so this example says use the remainder theorem to find f of k, and then they tell us that f of x is equal to x squared plus 2x plus 3, and k is equal to 3 plus I. So what does this mean, or what do they want us to do? Well, we're working with synthetic division in this section, so we're going to go ahead and use synthetic division here, but now we're going to divide by 3 plus I. And so we're going to use this as our k. So we're going to have 3 plus I on the outside of this box that we've been creating. And again, we're going to go ahead and put our coefficients for the function here. So the coefficient for x squared is just 1. The coefficient for just x is 2. And the coefficient, or the number by itself at the very end, is 3. And notice that we're not missing any powers of any kind. I mean, the highest power here is a square, so that means we should have a 2, a 1, and then no power at all, and that's exactly what we have. So we don't have to fill in any missing zeros or anything like that. Here I'm just going to rewrite the 3 plus I. Let me just do this in white. So we're going to go ahead and divide by 3 plus I, or we're going to use, 3 plus I as our k value. So again, we're going to go ahead and follow the process for synthetic division. So step 1 would be to drop down this 1 here, and so we're going to have 1 there. And now I have to multiply. Now I'm going to multiply 1 times 3, well that's just 3, and then 1 times I, well that's just I, so it's going to be 3 plus I there. And now I have to combine, so I have 2 plus 3 plus I. So I can think about it like this off to the side, 2 plus 3 plus I. Well, 2 plus 3 is simply just 5, and so we're going to have 5 plus I, and so that's what I'm going to write here, 5 plus I. Now this part, I'm going to have 5 plus I times 3 plus I. So it is 5 plus I times 3 plus I. Well, we can do that work off to the side, so now I need to multiply. So I need to multiply 3 plus I times 5 plus I. And we're just going to go ahead and distribute this out. So 3 times 5 is 15. 3 times I is 3I. I times 5 is 5I. And then I times I is I squared. And what I'm going to go ahead and do is combine these like terms. For example, I have 3i plus 5i. So this is going to give me 15 plus 8i plus I squared. And there's one thing that you just have to remember back from chapter 1 at the very beginning of the semester. When we discussed complex numbers, we had a definition that said I squared was equal to -1. So if you don't remember that, I'll write that here. We had that I squared was equal to -1. So what I'm going to go ahead and do is replace the I squared with a -1. And so this is going to allow me to combine 15 with this -1. So 15 minus 1 is 14 plus 8i. And so again, this value right here was the answer that I got when I multiplied this times this. So that means that 14 plus 8i would go here. And then I just combine like terms here. So 3 plus 14 would give us, let's see, that would give me 17. And then I just bring down the 8i. And it looks like that would be my remainder. And so if they're asking us to use the remainder theorem, that means they want us to find f of k. So that means that f of our k value, so what was the k value? Well, that was simply just f of 3 plus I. Well, that's just going to equal our remainder, which is 17 plus 8. Oops, let me erase that really quick. 17 plus 8i, and that would be our answer here. So let me just go ahead and put a box around it. So there we go. So our answer is 17 plus 8i.